Okay, one more example of finding a confidence interval for the mean. A random sample of state gasoline taxes in cents is shown here for 12 states. Use the data to estimate the true population mean gasoline tax with 90% confidence. Now, I'll just warn you that I don't remember where I found these numbers from. It's been a while, so I'm sure they're no longer accurate, even if they once were. But for the sake of the example, we'll pretend they are. So pretend that you want to know what's the average state gasoline tax for all the states, but you don't want to go through and track down every one of the states. So you just randomly select 12 of them and find out for those 12 states what they're charging for a gas tax. And that's what these 12 numbers here represent. Now, to calculate the confidence interval using that formula, you would need to know the sample mean and standard deviation. And way back earlier in the semester, we talked about how to calculate those, how to take a bunch of numbers and you calculate the mean by adding them all up together and dividing by how many there are. And you calculate the sample standard deviation by taking each number minus the mean, squaring all those differences, adding up the squares, dividing by one less than how many numbers you have, and then taking the square root. So we could work through all of those steps right now, or we could put all those numbers into a graphing calculator, an Excel spreadsheet, a statistics program, or something like that that would do the calculations for us. Now here I've just gone ahead and told you what the results of those calculations would be. The mean, if you add all those numbers together and divide by 12, is 23.2. And the sample standard deviation, if you calculate that, is 4.878. So let's put all that into the formula for the confidence interval for the mean. Okay, so we've got our X bar and we've got our S. And what's our N? That's the sample size. That's how many individuals we have in the sample, and that is 12. And what's our T sub alpha over 2? Well, we'll have to look that up on the table. So for a 90% confidence interval with sample size 12, which means degrees of freedom is 11, on table F, I see the number 1.796. So that's what we're going to be using for T sub alpha over 2, 1.796. So X bar 23.2 minus 1.796 times 4.878 divided by the square root of 12 is 20.6709, about 20.7. And then that's the lower limit. Then the upper limit is same formula, but with a plus. 25.729, about 25.7. So the confidence interval is from 20.7 to 25.7. What if we wanted to use the special built-in calculator function? Well, we could have the calculator take care of all of the calculations for us. Just give it all the numbers and it would find the sample mean, the sample standard deviation, and the formula. So if I wanted to take advantage of that, I could push Stat, Edit, and right now I don't have anything in here. If there was anything in here, I'd want to clear out the data. But I'm going to type in these numbers, 21.5, enter, 23, enter, 16, 20.7, 25.9, 20, 25.3, 17, 28, 30, 20, and 31. Now I'm going to push stat again, go to tests, go to t-interval, and this time I want it to look at the data, the individual data values that I entered. So I'm going to select data. I put the data in list L1. Frequency should be 1 because each number only counts once. And my confidence level was 90% or 0.90. So now I'm going to ask it to calculate. And it told me that X bar was 23.2, told me that S was 4.878, N was 12, and my interval goes from 20.671 to 25.729, or about 20.7 to 25.7. So to sum up, if you understood what we were doing in section 7.1 last time for calculating confidence intervals, you only need to learn 2 new things from this section. One of those things is, how do you know when to use a z-interval and when to use a t-interval? And the answer is, it depends on whether you know the population standard deviation or only the sample standard deviation. If you know the population standard deviation sigma, you use a z-interval. If you only know the standard deviation of the sample, S, you use a t-interval. The other thing you need to know is how to find the number that you put in for t to find that t-interval. And that's based on looking it up on this table F. If you do have a graphing calculator and you're using its special built-in function, all you have to remember is whether to select z-interval or t-interval off of the little menu.